So in this video, we're going to be doing solving equations that already have logarithms in them. And we have three different types of equations that we're going to be looking at in order to do so. So for this first one, this is one very similar to any type of solving where our biggest function is the logarithm, but we have other things going on as well. So when I see something like this, I know that I'm going to use SEDMEP. And once again, this is just the opposite order of operations. So this is the order that I'm going to try and isolate my x. First thing we always ask yourselves, is there anything I could add or subtract to the other side? Once we've done that, we then go to the next bit and say, okay, what about dividing or multiplying? And I see I have this 2 out in the front. Now some people might say, hey, with my power rule, I can make that an exponent. And whereas you could, it wouldn't necessarily be a useful help because once again, we're just trying to get rid of things. So I'm going to divide by 2 on each side. That cancels out on the left, leaving me with a log base 2 of x minus 1 is equal to 3. Now this next step is pretty cool. In order to get rid of the exponent, in a logarithm, it's just another way of writing an exponent. So we're in this stage here. We're going to go ahead and we're going to do what's known as exponentiating both sides. An exponent undoes a logarithm. So I'm going to take the base of my log and I'm going to write that here on both sides. So now this logarithm has become the exponent. This 3 has become the exponent. The purpose of doing this is to undo, just like adding the 8 undid, dividing by 2 undid. Here, this undoes. This leaves me with x minus 1 equals 2 to the third, which is 8. Go ahead and finish solving it out. You get x equals 9. Now, logarithms have one other thing we have to check for. The argument of a logarithm must be a positive number. That means it must be greater than 0. So anytime you solve one of these, we need to always double check that if we plug our value of x in, we end up with a positive number. Now 9 minus 1 is a positive number, so therefore this would work. So this is one way of solving logarithms. Really, we're always doing this process. It just looks a little different each time. But this step here is something that we're going to do every single time. So if we look at this other one, before I want to get into solving anything, I immediately notice that I have 2 logarithms. If I have 2 logarithms, my brain should be telling me, hey, there's properties I can use here. I notice there's subtraction between the 2, and so we can use the quotient rule to go ahead and condense these into one logarithm. So doing so is going to give me the log of 2x over 5. If you aren't sure what happened here, please go watch one of the other videos on the properties of logarithms. That can explain the step that I took from here to here. Well, now the only thing I have is the log, so I don't need to do the SAD. I don't need to do this part. There's nothing. I just need to get rid of my exponent. So I'm going to look, and I'm going to find the base of my logarithm. Since there is no base written, I know this is a common log with a base of 10, and I'm going to exponentiate. That means I'm going to do 10 to this log, 10 to the 1. Cancels on the side, leaving me with 2. X to the 5th is equal to 10 to the 1st, which is simply 10. Go ahead and finish solving. Oops, that should be divided by 2 there. And we get x equals 25. Because I did start with logarithms, I have to double check once again that if I plug it into my argument, I get a positive number. So I'm going to plug in 25. That would give me a positive number, so we are good to go. So a normal equation with all the different numbers, follow that SEDMEP. When you get to the stage, when you're getting rid of your logarithm, to undo a log, we exponentiate. We take the base of the logarithm, we turn those into exponentials on both sides. Same thing here. Once we used our properties to condense it down to one logarithm, we found the base of our log, exponentiated both sides. So there's one other type that we can see. This one looks kind of similar to the one above where we have multiple logarithms going on. And so I'm going to do that same first step. As soon as I see multiple logarithms, I'm going to go ahead and condense them. On the left, it's multiplication because there's addition here. So this becomes the log of x times x plus 1. On the right, if there's subtraction, so that's going to become division. So that becomes the log of 4x divided by 2. Well, 4x divided by 2 is just 2x. Now that I'm here, there's a handful of different ways I could handle this, but let's follow the way we've been doing. We could go ahead and exponentiate. So the base here is a 10, so I'm going to do a 10 here. That cancels out. I have to do the same thing on both sides. Well, luckily, this is also a 10, and so it also cancels out, leaving me with just x squared plus x equals 2x. Now, in order to finish solving here, I notice that this is a quadratic, so I'm going to try factoring, which means I need to set this equal to 0. So I'm going to bring this 2x over. In order to factor this, I notice that it's x squared and x. They both have an x in it. So I'm going to factor that x out to the front, which is with x times x minus 1. Set each of these equal to 0 to solve. And I get two possible answers of x equals 0 and x equals 1. But I'm not quite done. In order to double check, because it's a logarithm, I have to take any of my arguments that had an x in it and plug it back in. So x, x plus 1, 4x. So I'm going to plug in 0. That's 0, 0 plus 1, and 4 times 0. I'm checking to see, is it positive or is it greater than 0? Here, 0 itself is not greater than 0, so it did not work. 4 times 0 is not greater than 0, so it did not work. So I'm going to actually cross that one out. That answer is extraneous. I have to go and check the 1 now. So it's going to be 1, 1 plus 1, and 4 times 1. 1 is a positive number, so I'm good. 1 plus 1 is a positive number, so I'm good. 4 times 1 is a positive number, so I'm good. This is my final answer for this problem. So this is the step here, like I said, that is unique to logarithms. And to undo a log, we exponentiate. So we take whatever was the base of the logarithm, and we create that as a base of an exponential. Whatever we had in our equation becomes the exponents on both sides. And that doesn't matter with what type of logarithmic equation you start with, we can always do that step.